Today we'll continue our series on VPC. So if you think about what we did the last time, it will take time to build a complete VPC. But what I was really trying to show the last time, if you got the concept clear, honestly, there's nothing different about that from VPC. I think I stressed out the fact that the most important thing is in VPC is the first of all the CIDR planning and the subnet planning, right? So CIDR is just as an organization, you pick a big CIDR, you break it down into VPCs. Then within those VPCs, you just split them into subnet. There is no rule. There's no rule on how you split your subnet. It's basically your size, like and also when you keep expansion at the back of your mind, right? So you know that as time goes on, you may need to bring in more compute or whatever. Like it just depends on your immediate use versus how you're going to grow. That's how you build those subnets. So sometimes maybe a subnet can only take like 1,000 IP addresses. So it means you can only support 1,000 resource in that subnet, right? If you needed more, there is room for you to go, right? And I think we looked at the default VPC. We saw honestly for most accounts there is the default VPC, but people usually get rid of it and just keep their own private VPC, right? But it's there if you wanted to see like an ideal VPC setup. And at some point we'll do a lot with VPC. There's just a lot that you continue to do with VPC. So we saw how internet gateway, when you needed internet access, main route table, you could add your own, specify exactly what route you wanted there. Default security group, you could also create yours, right? That decides security group is like a firewall for the instances, right? We've seen it. It works for EC2 machines, your RDS databases, Elastic Cache clusters. They all need like a security group that decides who can get to them, right? So we've established that. So what are we going to be discussing today? We'll continue the series. And so when you now think about it, right? If you have one VPC, so what we saw the other day was one VPC, but at times one VPC needs to talk to another VPC. And that's the concept of VPC peering, right? So just think about it that if one VPC needs to communicate with another VPC, because we said the VPC itself is a private virtual cloud, right? So it's private. So if one private entity needs to talk to another private entity, another private VPC, then there is need for, you need to pair them together, okay? So network connection between two VPCs, right? Two more VPCs, and then works across regions and accounts. So it means that if you have your account, I have my account, I have my VPC, you have yours. If we really want to share information together, whether I have an application that I hosted in my VPC and I needed it to see it, why not? We could pair our VPCs, right? We could pair our VPCs and then you could see the application, right? And you can also have two VPCs you created, whether in two different regions, two different accounts, it doesn't matter. The most important thing is that you can really, with the VPC IDs, you can pair them, and then connection can flow between them, right? But there is only one thing about VPCs pairing that you just need to know. It's just the fact that it's non-transitive. And it's very simple. The fact that you connecting from A to B, and if you connect B to C, it doesn't mean A can reach C. That's just what it means. I don't think there is nothing special about it. It just means that the connection is not inherited, right? So if I connect A to B, like in this diagram, A is connected to B, A is also connected to C, but it doesn't mean B and C are connected, right? Because it's non-transitive. So it's only the relationships that you create, those are the ones that exist, okay? That's just the only one of the setbacks of VPC, and we'll see how AWS tries to solve that. But it's just the fact that these relationships that you create, they're non-transitive. So one-to-one relationship, that's really what it means. So in as much as you want a VPC to talk to the other VPC, you have to establish that connection. And there's nothing like, oh, this guy is connected because I'm connected to that guy, I can reach it. There's nothing like that, right? Uses private IP address, obviously, right? And no single point of failure or bandwidth bottleneck. And that's the whole idea, right? Because if you create those connections, it just means that you're basically connecting two VPCs, and it's just very easy for you to create those more isolated networks, even across different VPCs, right? So it's not hard. Even creating VPC pairing is not. There's nothing there. You basically create a pairing connection, you accept it on the other hand. So it's nothing. The most important thing you just need to know is the concept that it's just for you to create that physical connection between two VPCs. Remember, two VPCs, when you say, for example, one is in one region and the other one is in another region, you know what a region is. A region are two geographical locations far from themselves, right? So you connecting it is just like you're bridging that gap and using the AWS network to basically, establish that connection. Ideally, if it was in the real world, you do a lot of routing and all, but AWS makes it really easy. Like cloud, that's what the cloud does. Okay, so there's nothing much to talk about VPC pairing. But it does have some limitation. I think I've already shared it. Number one, no transitive pairing. So what it means is that A, B, C doesn't mean A can talk to C. It's what it is, just like that. And overlapping CIDR is really one thing you need to take note of. So overlapping is really, you can't really have CIDRs overlap, meaning they have to be distinct. That's one of the major disadvantage of VPC pairing. So what it means is that before you can pair two VPCs, their CIDR, you see this is the way we're designing the CIDR. It means where one ends, another one has to continue. You can't have CIDRs that are overlapping, like maybe one is inside. And the way IP addressing works is that sometimes an IP is a subset of another IP. So you can't have an IP, you can't have a CIDR that is a subset of another CIDR, and then you're pairing both of them. It doesn't work for VPC pairing, okay? No edge-to-edge routing through gateways. And what that means is that we've seen how we've used NAT gateways, internet gateways. So you can't say, oh, because I'm connecting to this pairing, this VPC, I can use some of the gateways that this other VPC has. That's just what it says, and that's what it means. So what it means is that if I connect to a VPC, I can't really inherit the internet gateway of that other VPC. So if that other VPC has an internet gateway, I can't use pairing connection to inherit that, right? But we'll see some of the other solutions that solves that for you around right out of the box, right? So DNS resolution also requires configuration. Yeah, you basically need to do some configuration for you to have DNS resolution even within those pairing connections. Okay. Security groups, we've seen how security groups references another security group, right? But you can't say because, oh, my VPC is paired to your VPC, I can make reference to a security group in your VPC. It doesn't work that way, right? And obviously the alternative is to use transit gateway because it really simplifies these things. All these limitations that I've just listed, you can transit gateway solves that. So like with the transit gateway, you can have just one internet gateway that everybody uses. Transit gateway can make that possible, but VPC pairing is not going to. But at this level, honestly, just know what VPC pairing is. That obviously is transitive is non-transitive in nature. It doesn't support overlapping CIDRing. Those are the three major things that you need to take. Those are the three major things you need to be aware of. Okay. So which brings me to one of my very favorite topics, which is VPC endpoints, right? So we've seen a VPC, right? So there is VPC, and we just said you can also connect one VPC to another VPC with the concept of pairing, right? Which is the simplest way to just bring in two VPCs together. But you will see that sometimes you are in the AWS, you already have your workloads on AWS, and sometimes you want to use other AWS services, right? But you don't want to go over the internet to do it. You pretty much have like a workload that does not have internet access, right? But you want to access other AWS services. It could be S3 bucket, it could be SNS, all the services AWS provides. You want to use them, but you don't want to use them via the internet. That's really what VPC endpoints. That's just what it serves, right? So free, especially for gateway, you'll see how VPC interface endpoint is not free, but for the gateway, free private connection to AWS services. So just think about it that way. Remember, AWS services in this case could be the service AWS exposes, right? But at some point, it could also be your own services, right? So you could have your own services and expose them privately. The most important thing is that private connection. So you are creating private connection to like an AWS resource in this case, okay? It will use the same DNS name as the service. So what it means is that nothing is going to change. You won't even notice, right? But behind the scene, it's actually a private connection. And we'll see that example, right? So for gateway, yeah, you can use, obviously, if you have like a private, what do you call it? If you have like public IP, an instance that is public, routable by the public internet, it still will use that private connectivity is the point, right? Gateway endpoint is free, like I mentioned, only supported for S3 and DynamoDB. There is an entity there where like a route table is updated to show that if you are going to this service, use this route configuration, okay? Which it differs a bit from VPC endpoint because for VPC endpoints, you're not dealing with route tables, okay? So obviously no data transfer, right? No charges, right? Because you are keeping that, you're keeping it private to you. Support VPC endpoint policies. It doesn't require internet gateway, meaning you don't need to be on the internet for that to happen, right? So cannot be accessed from on-premise. Obviously, it's one of the limitations the gateway will have. You can solve that using interface endpoints, but that's like advanced subject, right? Cannot be accessed from other AWS region, yes, because gateway is basically gateway, just your gateway to DynamoDB or S3, right? If you really wanted to do cross-region stuff, right, to your account, then that's when like an interface endpoint comes in, okay? Which obviously takes us to the next topic because we really need to talk about both of them and see the difference, right? So it's still private connectivity from your VPC to AWS services without using the internet. It's similar. The concepts are really similar, and we'll see from the demo that both of them are actually the same, right? So they're similar. The one thing you need to take out for VPC endpoint is the fact that there is an ENI, Elastic Network Interface. Really, because if you understand that concept, when you start talking about private link, it becomes very easy. The other one uses route table, creates a configuration there, but VPC endpoint actually creates a physical ENI. So it's like it creates a physical connection for you to get to the other side, right? Privately. So that's a very huge distinction between VPC endpoints and the gateway counterpart. But it's the same, they're doing the same thing, right? Sometimes you can actually use endpoint specific DNS name for the service if more or less like you're going, if you created like a VPC endpoint for a particular service, sometimes you can actually go directly to use the VPC endpoint for that service, right? Obviously, it's powered by PrivateLink, and we'll see PrivateLink is really no big deal, but VPC endpoint is actually VPC endpoint interface endpoint is really what powers PrivateLink, and is the fact that because of that ENIs that you're creating, you could actually expose a service over a private link, right? Whether from your own region to another region or from your account to another account, in a private manner. DNS resolution to private IP addresses, obviously. So what it means is that, yeah, all that is going to happen privately, and you still can resolve the IP address that is on the other side. But it comes with charges. So gateway we saw is free. It's free. If you have gateway for S3 and DynamoDB, it's going to be free. But for any VPC endpoint you create, there's charge over. But again, the beauty of it, it solves many of the problems we saw. So you can access it via direct connect, via direct connect connections, VPN connections, and when you see DX is just direct connection. So VPN connections, direct connect connections can use interface endpoints, which makes it really, really good. So you can access it from other regions, right? So once there's like a pairing transit, once there's that connection between two of them, you basically can use interface endpoint, right? And sometimes also you don't even need that, even the pairing to happen. Right? You can actually use your interface endpoint to actually expose a service, right, to a completely different VPC. And we're going to see that as time goes on, right? But these are concepts that once you understand them, it becomes very, very easy. So before we go to PrivateLink, let's just go through these two that we've seen. I'm here in my account. I'm just going to go. I hope you can see it clearly. So I've tried to zoom in so that we'll go to where we stopped the last time. So if you remember, we did, as part of the last class, let me go to instances, right? There was this private instance that I created. Obviously, it's a T2 micro. I still have it running, right? But if you remember, what we did that day was to use this instance. So what I did was to extend the default VPC. I created a private subnet. I launched the EC2 instance there. I did put like an instance connect just for me to gain SSH access into the machine, right? Which is what I did. So the machine is still there. The only thing that I've done before this class is that I've gone to remove the, so let me go to VPC. The only thing I've done before this class is to remove the gateway, the NAT gateway that we added. So if you remember, there was a time we added like a NAT gateway in a public subnet to allow that private instance to go to the internet. That's one thing we did. We did it in the class. So I've taken that out, but my connection still exists. So if I go to this private instance and I try to connect, so if I go to connect, I would use my private instance, right, to connect. I'll use my existing instance connect endpoint that we created on the call. So it's still there. So if I do connect, I'm still going to be able to connect. The only thing is we are back to the point where we had no internet. So this machine as it stands, it doesn't have any internet connection at all. It doesn't have. So that's why I had to create that instance connect endpoint for me to be able to SSH directly into it. Because in an ideal world, because it's private, there's no way I can get into it. I would obviously go through a bastion host, go through something that is in the public subnet, then go from there to the private subnet. But in this case, I'm getting to it directly. And we've seen this already, right? But one thing you'll notice in this one is that if I do ping, let me just say I do curl google.com. Let me just do this. Sorry. Yeah, that's what I want to do, google.com. It's not going to work because I know this machine has no connectivity to the internet. So it's just going to stay here. I know. So right now I can't connect to the internet. And honestly, when you're dealing with AWS, there are machines like that shouldn't even have any business to do with the internet, right? There are some that maybe needs to go to the internet to download stuff, but you may have workloads that are completely isolated from the internet. You don't even need them to have internet access. But as much as they don't have internet access, but you want them to be able to do things within the AWS infrastructure, right? Maybe fetch files from S3, send requests to SNS and all that. You still want all that to happen, right? Even if you don't want to go to the internet. So that is where your endpoints come in. So in this case, we're going to start with a gateway endpoint, and you see how that works. Right now, we know this guy cannot connect to the internet, but we still want it to be able to use some of the AWS services that are out there. So the first thing we're going to do is we'll go to endpoints. So we're going to do endpoints. Let me just type endpoints and see. So VPC is a VPC feature, so I'll go there, endpoint. Remember, gateway can only be created for two services, S3 and DynamoDB, right? Okay, so I have one endpoint here, so I'm going to create a new one. So yeah, I'm going to call it my S3 gateway endpoint, right? The most important thing is just know why you're creating it. We've already seen the problem. The problem is that I'm in an account. That account does not have access to the internet, but I have a bucket, right? Maybe let's assume that account has a workload in there, like maybe it has like a machine, it has like an application that is running that needs to push something into my S3 bucket, right? something like an S3 bucket that you own. There's no way it's going to happen now because you don't have internet access. So you need to. That's why we are doing this. You just need to know the use case. Why are you doing something? Once you know that, it becomes very easy. And like I showed you inside here, we don't have connection to the internet, but we need to be able to do something with our S3 bucket, right? So the first thing we just need to do is that if we go back here, we'll be creating an S3 gateway endpoint, right? And here we're going to just type S3 and search. When you do search, you're going to see all the options for S3. I'm particularly interested in this one, right? There is this one and there is this one. The first one is the gateway, right? So I'm going to choose that one. That's really the one I want to do. You obviously need a VPC to connect it to. So I'm going to use this VPC, right? Once that is created, you now need to tell it which route. So once you create this gateway, which route am I going to update so that it knows that if it needs to go to the S3 service, it's going to use this information to get there. You remember I told you how important your routables were, right? Because that's really where you find out if I want to go somewhere, this is where what will tell you how to get there, right? So I'm going to tell it this private routable, that's the routable my private instance needs to, is the routable my private instance is currently using. So now I'm saying that's the routable I want to associate with this, right? So full access, let's not talk about the policy for now. But again, I'm going to show you something about that when we go into interface endpoint, but the concept is the same. So I'm not going to bother you. I'm not going to bother about it here. So we're good at this point. So the gateway, the endpoint is now creating. So let me just go back here and check. You'll see two endpoints. This one, I think it became available almost immediately, right? Okay, so if I go back to my instance connect and I do AWS S3 LS, obviously it's telling me this. Does anyone know why this is happening? You know that if this is happening, it just shows that this EC2 instance does not have any role associated with it, right? So it doesn't ideally, it shouldn't be asking me to for credentials if it has like a role or permission attached to it. Ideally, it says I should run AWS configure, but we know that's not good practice. The good practice is to give it an IAM role. So we're going to create one on this call. So I'm going to do IAM. I'm not sure why my PC is a bit slow, but I'm just going to go IAM. So we're going to create a role right now. We'll create a role. So here, I'm just going to go to roles. I will create one role. I'll call it, what is going to use this role? Obviously EC2, right? So EC2 is going to use this role. So I'm going to say it's EC2 role. I'm just going to do next. So I'll call it, I'm going to give it, because all the demo I'm going to show you is on S3. So I'm going to give it S3 full access. Just continue with me. So I'll do S3 full access. I'm going to call it my EC2 S3 role, just to be a bit specific. So role 2 for my EC2 for S3 access. Okay, so I'm just going to leave it like this. It has full S3 access for now, so no, that's not a problem. It said the role already exists. Okay, so let me call this on my main EC2. I'm going to create the role. Okay, so it's creating that role, or it has created it. So I'll just go back to my EC2 instance, and then this is the instance. I'm just going to go to security, right? So I'm going to modify the IAM role. Right now it doesn't have one, so I'm going to choose the one that I just created. So I think it's, let me refresh it. Did I just create that role in the wrong region or what? Where did I create that role? It's this one, right? My main, why is it not showing up? Let me check. Let me type main. Interesting. My main EC2 S3 role, trust relationship, EC2, yep. Not sure why it's not showing up. Let's see. It won't show up, but obviously I have one already that I created. It's not showing up. I don't want to waste time on that. So I already have one. So let me just show you. Yeah, but I did choose this one as my main EC2. So I'm not sure why it's not showing that. But there is also this one that I've created before, and you see it's the same policy. It has Amazon S3 full access, so it's fine. Let's just continue with that one. So I'll just use that one, and then I'll update the IAM role, right? So I will update it. Then I'll go back to my instance, and here I'm just going to do AWS. I'll use the same command that I ran before. So I'll do AWS S3 LS, and you can see automatically the bucket is showing, right? I know I have this bucket. If you go to S3 bucket, there is this bucket. Prior, I could not do that, right? But now, once I added a gateway, once I added a gateway endpoint for S3, I was able to do what I'm supposed to do. So now I can more or less like interact with AWS services privately. This guy is not on the internet. And so let's just go back to what happened behind the scene. there is just one major thing that happened. If you go to the subnet, so this is VPC. If you go to the route, if you go to the route table and you go to the private subnet here, one thing you will just see is that if you go to the routes, sometimes it takes, I don't know, let me refresh it. Let me refresh and see. So if you remember, I think in our previous classes, we used to have this one, right? We have this local one. I know there were other routes where we did NAT gateway, but that is no longer here. But one thing you notice is that if you check PL/something, it says use this VPC endpoint. And this is the one we created, the gateway endpoint. That's the one we created. And when you see in your account, you can actually go to manage prefix leaks. So just so you know, it's not just S3. You can create yours. You can basically have like a prefix leak where you can direct traffic to, right? So if I come here and I search, it's good you know some of the details involved, right? If I search here and I do enter, you see it's just saying that if you are going to this prefix list, right, and it has S3, use that VPC and that gateway endpoint. Cool. And then for that reason, we are able to list buckets, and we can do any S3 operation, right? So it means that the only thing here is that because this guy doesn't have internet access, if you still need to access other services, SNS, all these services, you have to go and create specified endpoint for them. And we know that gateway endpoint only supports S3 and DynamoDB. So that means for the other ones, you have to create interface endpoints, right? Cool. So let's go back. So what we'll now do is that we'll go back. I hope this is clear. That is gateway, right? Gateway endpoint. We created a gateway endpoint, which was a VPC. It automatically updated the route table and put the route for us, saying if you're going to this destination, use this gateway endpoint. And just with that, we could access S3 resource without being connected to the internet. So that one is sorted. So let's go back to the endpoint, and then we'll now talk about the very interesting and a bit confusing one. So if we go to the endpoints that we created before, I'm just going to go to endpoints. So in the endpoint here, I'm going to delete the endpoint. So delete this one. So I'm going to delete it. Delete the VPC endpoint. I'm going to type delete here and delete it. So it's gone. Now that it's gone, what do you think is going to happen if I do this, right? It's going to be stuck here. It's not going to work again. So it's gone. It means we can't connect again. It's that gateway that was helping us, but now we can't connect. So if I also go back to the route table, what do you think I'm going to see? We are obviously going to see a black hole that says that route no longer exists. So if I go to route here, you will notice that, okay, I think he obviously deleted the route on our behalf, right? So he created it, he deleted it once it was gone. So now it's gone, right? So the route is no longer there. And for that reason, basically this same thing is not going to work. You see, it's stuck there. Let's do the same with interface endpoint, and let's see what is going to change, what the difference will be. So we'll go here and we'll go to the same endpoints, right? So we'll go to VPC, we'll create endpoints, right? We'll call it S3 interface. But again, remember, I'm doing this for demo because S3 is easy for me to show. There's no reason why you should create S3 interface endpoint because you know the gateway endpoint is free, right? For the most part, you want to use gateway endpoint unless you're using PrivateLink, right, to expose something around S3 to another account and you just want to use interface endpoint. Ideally, if it's S3 DynamoDB, you should use gateway endpoint because those will come in free, right? But again, I'll show you an option in there. So I'm going to call it S3 interface endpoint, right? So I'll call it this. So in this case, okay, yeah, so AWS service is in this case what we want to expose. We're going to be doing S3, right? So like I said, there are two options. So there is the gateway option and there is the interface option. So I'm going to choose the interface, right? So the network settings, I still have to give it a VPC, right? This is important. Enable DNS name, right? The idea is just so that you can basically just everything will just work the same because the idea is that it will create a route behind the scene that makes everything to be more or less like transparent to you, so you can do the same operation that you are doing without really specifying directly the DNS name of the VPC endpoint, right? So here I'm going to turn it off because if I enable it, it means that for outbound traffic, for example, from AWS, they can use the interface endpoint, but inbound traffic, maybe from your direct connect or your VPN or your VPN connections, they can use the gateway endpoint, right? But we can turn it off right now because we don't really have a gateway endpoint enabled. This is where I'm now going to choose which subnet. If you remember when we extended the VPC, we did create an extra subnet in US West 2A, right? Which is the one called my private subnet, subnet easy. And so I'm going to use this one, right? So once I have that enabled, ideally you're meant to have like a security group for it, but I'm going to reuse this instance connect SG, right? I'm going to use this one here. And the reason is because they are similar. You just need ports 443 enabled, right? And I know this one already has that. Ideally, I'm supposed to create, you can create one, right? You can create. So if we go and look at the security group, if we go and look at it, what you will notice is that it has just one inbound rule. And it says that the inbound rule says, in this case, So inbound rule is HTTPS, right, from everywhere, right? So you could trim this down anyhow you want, but it's fine. But the most important thing is that you just need to allow HTTPS on 443. So I can reuse it just so that you're not confused. You can always create one specifically for that, right? But in this case, I'm using the same because it's the same inbound rule, the same port and all. So I'm going to choose that one. So I'll go to, where was I just now? I was here. Nope. I think I was here. Okay, I was here. So I'll choose this and then full access for now, right? I'm not going to do anything. I'm just going to leave it as is. And then I'm going to create S3 interface endpoint. I'm going to create it. Interface endpoint is obviously is going to take some time, right? Because it creates like an ENI, right? So it's going to create like a network interface. A network interface is like a physical connection. It's more or less like it's throwing something inside your VPC that allows that connection to happen. And the interface endpoint is very, very important because when you start doing things like transit gateway, where it will create an ENI in your account, you need to start appreciating, especially for example, EKS. There are many more advanced models you begin to see where the model exists or the service exists, but it drops an ENI in your VPC just for you to be able to create that connection. It's the same way VPC endpoint kind of works, right? It's going to create a network interface behind the scenes. So actually, if we check for network interface, I'm going to go here and say network interface, and let's see network interfaces. So let's see the ones we have. We used to have two. I think they will now be three. Okay, one is for the EC2 machine itself. The second one is for the first endpoint I created, and the next one now, which is the most recent, will be for the one that we just created, which is this one, this VPC endpoint, right? So that's one thing you should take note. The other one was using a route table. This one is using a network device, right, to make it happen. So it's there. It has given us a private IP. We'll just give it time for the VPC endpoint to be created. So I'm going to refresh this. It's still creating. It's going to take time. But remember, at the end of the day, really what we want to achieve is still be able to go back and do AWS S3 LS, right? Right now it's still not working, but let's wait for our endpoints to come up. Okay. I think it's creating here. It's going to take some time. We just need to wait. So one thing you see about the endpoint is also the fact that it has the subnets where it's deployed to. It's a private subnet in this case, meaning everything in that private subnet that needs to use it can use it to resolve whatever they want to resolve. Security group obviously has a security group that has 443 HTTPS enabled. That's majorly what you need to know for endpoint, VPC endpoint. And then we'll talk about policy at some point. But right now you see that everything is star, right? So I think by now you should know we've dealt with resource policies before now, right? So here it's like the endpoint has a policy. So it says for now action is all, the effect is allow, all principal, all resource, right? But we can tune that down as time goes on if we wanted to streamline it further. But for now, let's just give it time to create. Let's look for the let's see the endpoint and see if it has created. So we just go there. It's still pending. Usually the interface endpoint takes some time basically. So we just need to wait a bit. Let's wait a bit and see how it goes. Let me refresh. Yeah, it goes. Let me refresh. Like I said, interface endpoint is really what powers PrivateLink. We'll see what PrivateLink is. So you just need to know it very well because it exposes a lot of architecture, right? So for example, if you had like a SaaS application, if I had a SaaS application, an AWS SaaS application that I was exposing, right? And I was pretty much trying to give it to another account, your own account, right? This is one thing I can do. I can put the application behind, like use a VPC endpoint to expose it, and then it just becomes private link, right? And then whoever is connecting will use like something like this. But then the good thing is that with policies, you can actually now decide if the source is from this account, or you can use that to even limit who. So it's very powerful. There's networking as part of it, and there is also even policies that you can have in place just to make sure that you can only grant the people the exact access they need, right? So there's a lot of benefit that comes with it, especially around VPC the private link. Because before now, people, for example, if you wanted to, like, if I had like an application that I wanted to expose to a different account, we've seen how VPC pairing can solve that, right? But VPC pairing is like you're pairing one VPC to another VPC. It's like you're exposing a whole VPC to a different VPC, right? But in most cases, sometimes maybe it's just one application that you want the other person to be able to see. So why not expose just that application, right? That's where private link comes in. We'll talk about it. But interface endpoint is really what powers it. Okay, it's what powers it. So let's, it's still creating. It just takes time. It takes time, and if we go back and refresh this, it's still going to stay there. It's not going to do anything. But let's give it some time. Let's create the endpoint. Okay, it's available now, so I'm happy it's available. Let's refresh this and see what happens. Also, sometimes it takes time to propagate the change. VPC endpoint can sometimes you feel it's not working, but it definitely is going to work. So we will just give it some time to do its thing. So it's there, it's connected, so it's here. uh, it's basically using, what do you call it, we have the endpoint, it's fine, it's connected. It has this subnet, just one subnet. I'm just trying to confirm it's here. It's private subnet, security group allows 443. So it's fine. We just need to go back here and give it time. I can as well just try a different connection and see if that gives me a faster result. I'm just going to do this. I'll close this one. So let's see. So just clear my page and then do AWS S3 LS and see what happens. Yeah, you see that first one was like it was staying, it was there, right? But this one is working now. The point is that we've used two approach, right, to more or less like enable the same thing, right? And you can actually do, for example, you can do, so the bucket is listed here, right? So it's the same bucket that we were seeing when we were using a gateway endpoint. But now we're also doing the same using an interface endpoint, right? But I think I told you that it's cheap, it's free if you were using gateway endpoint, especially if it's S3 and DynamoDB, right? But for many of the other services, only interface endpoint is what they support. They don't support gateway endpoint. But the concept is the same. We still can list the same S3 bucket using a machine that is in a completely private subnet, right? That has no access to the internet. So we can do things like AWS S3. We could do CP. Okay, let's more or less, like, I think I have like a test file that I created here. So what it means is that I can do AWS S3, uh, but that's not actually where I wanted to go to. I wanted to do this. So if I refresh this page, if I go to object, if I refresh this, you would see that the test is here, right? So I've been able to upload the file. Right now, this file actually does not have, the EC2 instance itself does not have internet access. But again, I've been able to push it. I've been able to push it there. But again, what can we do? If you think about this EC2 instance right now, the guy has, if you check the role it's using, so if I go to security and I check the role it's actually using a, what do you call it? It's using a full S3 full access, right? So if you check, it's using S3 full access, but let's confirm. So it's using S3 full access. So it's here. So it means that it can do everything to S3, right? So S3 star is what it's using. But the thing is that at the VPC level, which is the VPC endpoint, interface endpoint, I can actually edit this policy and do action. I can say deny, right? And I can say, oh, sorry, action, I would say S3 star, right? And then I'll say deny. So I'm going to, I think my keyboard is somehow, and then I'll do the principal is going to be pretty much AWS. So so I'll do AWS, and then I'm going to do what again? I'm going to look for that role that it's using. So I know it's using this role, right? So I'm going to go back there to the VPC endpoints and then deny it. So I'll paste it here, and the resource is really star. So everything. So just deny everything, right? So the action is really S3 slash star. I can also be pretty more specific and give it the bucket, right? So I'll just do, maybe I'll just go, but again, let's just try with the star resource, right? What is this saying? Is this saying there is something wrong? Okay, I think there is a comma missing here. There is also a comma missing here. So S3 dash star is the action, deny, and then I'll save. And like I said, VPC endpoint, sometimes it takes time for the chain to propagate. So I'm just going to connect again. So I'll create a fresh connection, go here, and then just disconnect again. And then I'll remove this and try the action that I've done before and see what happens. So it means that although the EC2 instance has full access to S3, even at the interface level, I still can deny the person, right? So I can do things like, let's try this one again. It's still working, right? So one thing I also noticed is that sometimes it takes time. It takes time for this propagation to happen. But at some point, this endpoint policy is going to kick in. So right before it was this, but we've changed it, right? So if I refresh, there is now a policy that says deny this person, deny him, S3 action on all resource, right? So let's give it some time. Yeah, VPC endpoint is just one. It's one. Sometimes it takes time. You think what you did is not working, but it's actually working, and you just have to be patient. But let's wait. Let's see if I try it again if it's going to work this time. So I'll just try the same command. Um, yeah, it's still working. Maybe we can leave it. We'll come back to it. But the point is that the VPC, the interface endpoint, there was an ENI that was created for you. That ENI is in your private subnet. That's the ENI you're actually using to do the connection, right? This instance does not have internet. The other one will create like a route and use the prefix list. If it's a private, if the private instance is going to use the private connection. If it's a public instance, it's going to use the private connection to the AWS services, right? But the most important thing is that in both cases, you don't really need internet connectivity to talk to AWS services, right? So we'll give it this. We'll give this one time. It's still. I'm not sure why it's. Sometimes it takes time. Even the other time I was like trying it basically takes time. But by now it should, because now it's an explicit deny that we have here, right? Although the guy does have it does have like full access, but even at the interface level, you can actually block him and say you can't do this, right, against any resource, right? So sometimes, yeah, you see, like it's just a wait game. I was almost giving up, but you can see it now says access denied. Although the EC2 instance does have full access to S3, but even at the interface level, you still can decide. So if you think about it, if you move this to private link, if I expose the service using interface endpoint, it means that although even if from your own account, you have full access to do anything, I still can choose from the interface endpoint the people who I need them to have access. I can limit it to your VPC, I can limit it to whatever like I want, right? Just to make sure that you cannot be controlling your own permission against my resource in my VPC, right? That's one beautiful thing you also see with interface endpoint. So right now, this guy cannot do anything. Although from his own account or from his own standpoint, it does have like he has like full access to S3. But on the VPC endpoint side, he's been denied, and there's nothing he can do about it. Okay. I think that's it about that. Let's go back to the slide. So we've talked about VPC endpoint. Let's now think about private link. Really, is the technology that powers VPC endpoint that we just saw, right? So really VPC private link is really what powers it. And the idea is really secure connectivity between VPCs and services, right? So I think I've explained it even before getting to this slide, but you like this, if I have one service if I have a service in a VPC that I wanted to expose without exposing everything in that VPC, the private link can help you do that, right? So it means that you can actually expose a complete, just a service. VPC, if you were to do VPC peering, it's like I'm pairing this VPC completely with another VPC, but you can actually go a different route and just use private link to expose a single service. Okay. So traffic also never leaves the AWS network. We saw it when you were not connected to the internet and you still were able to more or less like reach out to your resource in the account, right? So supports the third-party services in AWS Marketplace. It's highly available and scalable, alternative to VPC peering for service connectivity. So VPC peering, it's good if they are your VPCs, you really want that full mesh that full connectivity, right? But if you just wanted one service to talk to another service within two VPCs, then private link is the option. Okay, so for example, if we wanted to go the other route where we're creating like a VPC, like an endpoint, right? If you go to an endpoint, for example, if you wanted to create endpoint, you see that there are some options, right? Some marketplaces, so if you have like a solution that you're exposing via the AWS marketplace, you can expose it via private link, right? You can also use your own private link basically to expose, like, for example, partner services, your own resource like relational database, like RDS. So there's just so many benefits that private link comes with. But I think until we do like a very typical until we see like a full example is when you appreciate it. But the concept is the same. You're basically exposing the service using an interface endpoint, and then whoever is connecting is also using interface endpoints to also gain connectivity to that service, right? So yeah, that one is a bit that one is going to be complex. We'll obviously show that at some point, talk about it in depth and see how you create connectivity between two services in two different VPCs without no peering connection, even in two different accounts, right? And if we go next, what are some of the best practices when you think about like VPC? What we've seen, CIDR is one of the biggest, like your CIDR management, right? It's really one of the biggest. Maybe at some point, if I still have time, I'll just go through it. But again, use multiple availability zones. We know the reason. It's really for high availability, right? if you're doing within your test account, you don't want to, nobody forces you, but ideally it's good for you to spread your workloads across multiple AZs, right? Separate tiers, right? You could have web, app, database, break them however you want to. But the good practice is always for you to keep your database, your applications in pretty much private subnets and have things that needs to be seen by the user exposed to the internet, right? Security group and network ACL is something you need to make sure that security is good. VPC endpoint obviously for AWS services, right? It just helps you because instead of your traffic going through the internet, you can just have that private connectivity with your AWS services. And then VPC Flow Logs, I think I explained it at some point that it's a log that shows all the traffic. So everything you're doing within your network, you can see it. You can use it to trace who called what, which IP address was able to access a particular website and all that. So those kind of information you can get it from the flow logs, right? So for optimization cost, obviously, NAT gateway is free. NAT gateway is something you need to. If some people want to save cost, they will use NAT instances, right? So both of them do the same thing. It's just that one is fully managed and the other one you have to manage yourself, right? But I've seen environments where production use NAT gateway, development use NAT instances just to save money, right? And then VPC endpoint obviously reduce data transfer costs because your traffic is moving via the private AWS network. IPv4 address management, release unused IP addresses, please. So as part of many of the exercises that we're doing, always check and go to your IP Insight to make sure that you don't have any public IP addresses that are there, because if it's there, you'll be paying. Okay. Cross AZ traffic, obviously, at some point would do that more, but it just means that when traffic moves across AZ, there are some costs associated with it. Okay. So VPC flow logs, obviously, you optimize at some point. You check if you wanted to see how traffic is doing, if it's moving from one AZ to the other, and you don't want that. Sometimes you'll be analyzing the logs to see where is your highest inter-AZ traffic going, right? And you can use that to save costs at some point. Obviously, regular cost reviews, doing monitoring on your service can also help you quickly spot things that are going wrong, right? Common architecture, single tier, public subnet only. I think we've operated many on this pattern since we had like a default VPC, and every time we create an EC2 instance there, and we just what do you call it? We just use the public IP, right? So single, you can just have one public subnet, just do your thing. But you could also have like two tier, right? So have like public subnet for your web, and then your private subnet for your database. You can have that. You can also have three tier. You can have like subnets that the whole idea is just for you to reduce your blast radius. So if anything happens with one subnet, you know that you're fine, right? So some people do app, web, however you want to arrange. And in a lot of cases, people have hybrid, right? Hybrid is the fact that some things are in your VPC, some things are in an on-premise environment, and then there's like pure connectivity between the two setup. Okay, so and then multi-VPCs, obviously. Like I said, most of us we deal with one account, but in the real world, you have multiple VPCs within an account, multiple VPCs within the organization, multiple VPCs, and sometimes, in most cases, these VPCs they need to connect to themselves, right? And that's where the concept of VPC peering or transit gateway comes in, which is something we're going to discuss under the advanced networking conversations. But you can have all that. So it's still for use case consideration is basically for your pattern. So if you are just exploring, you can create just two subnets. There's no rule. There's no fast or hard rule. The most important thing, which subnet should go to the internet, which subnet should be locked down. You can create all that, right? And then what else? Troubleshooting, checklist, basically route configuration is one of the major things. So if something was going wrong, this thing is still something that is hard for a lot of people, but sometimes if something is going wrong, this is like a step-by-step flow you can do. Your route table is one of the most important because that's like the first point that tells you where can you go to. If you are going /000, you are going out completely, right? Where are you reaching? It helps you to know your next hop, okay? So it's like a good place to check. Security group also is something you need to also keep track on. Sometimes something is not working, pretty much maybe there's no security group that is allowing the inbound traffic. So you have to check. Network ACL, most times they're not really a problem, but sometimes you need to also check and verify. And then internet gateway, the internet NAT gateway, their status, if they are down or something is going wrong, you pretty much need to also be able to check there. And then C instance placement, your instance subnet placement. Sometimes you think, oh, you created an instance. That's why sometimes when I'm creating EC2, you see I'm trying to check, I'm trying to verify to make sure that I'm putting it in the right subnet, because just one, if you put it, instead of putting it in the private subnet, you put it in the public subnet, your expectation of what should happen to it in the private subnet is not going to happen, and then you'll be like, why is it not? So you have to just be sure. Once you design it, make sure that the right instance is going to the right place, right? And then VPC flow logs, obviously, is always going to be there for you to troubleshoot cost issues, connectivity issues, and some other issues that are there. I think I don't need to go through the summary again. I've gone through many of the things that are mentioned here. So VPC endpoints, like we saw, gateway interface, that basically can give you that private connectivity. We've seen how your NAT gateway, for example, you need them in the public subnet. for you to allow traffic from private subnet to go to the internet. But we've also seen how even without that, if you just needed to use AWS services, you can just using the private subnet, right? Proper planning is obviously essential for scalability and cost control. Okay, we still have some time, so that would make me go back to what I was sharing at the earlier stage. Okay, I just have like a verification to do. Just give me a second. Uh, all right, so let's go back to what I was saying. I'm not sure. I know this was a bit confusing at some point, but again, this is really one thing you need to pay attention to. Honestly, if you really want to enjoy your your subnet planning, okay, especially when you're planning subnet. I know the other day I was telling you about like the groupings you had, right? And I told you that, for example, when you see um, one of the first groupings, right, that we saw supported this subnet mask. What it just means is that this 8-bit, because you have four octets, right? You have 8, 8, 8, 8, right? What it just means is that this first 8 cannot be changed, right? So this is always going to be here. But every other thing, 1, 2, 3. So this remaining 8 plus 8 plus 8, which is 8 plus 8, 16 plus another 8, 24. All these becomes usable host, right? But I think a lot of the confusions that people have is really how do I break this further, right? The most important thing is because it is /8 and you have like 60 million here, you can, however you want to. So you can pretty much say, okay, just know that the first range you pick and the prefix you give it just tells it where it's going to start from and where it's going to end, right? So if you can play with this, honestly, you can build any kind of VPC, no matter how complex it's going to be, right? A lot of it, you will see how code, infrastructure as code still does all these things. Once you give it a side, I can break it into subnet with some calculations, right? But you can also play with these things yourself, right? So it means that, for example, if I think that a particular VPC, there is a particular IP address I actually want it to start from, the CIDR, you have to just decide the root CIDR, right? So if, for example, this is my entire organization CIDR, for example, like the whole organization that I'm going to use, I know that I have 16 million IP addresses. Yeah, you can decide to start breaking this further. You can come here and be like, okay, maybe the first one will start from you can even say start from 000 completely, right? Start from 000 completely, and then you can maybe say this is going to you can do this. Once you do this, for example, you see that this already breaks it into almost like half, right? One side already takes like how many million IP addresses. What you need to keep track of is really the last usable IP addresses: 110.127.255.255. Once I add this 255 here, it means the logical next address I need to start from is going to be 10. You can see 10.127. If I do 10.128, that's like a logical next address that I need to start from, right? Now it just depends on how much you want to break this further. You pretty much can just break it further. You can take this, split it however you want to. And I think I also showed you guys the other day. I said, for example, if you take 10 dot the second one, right, this 10.128, if you brought it here, if you did 10.128.0.0 and then you did /9 like we saw, the good thing is that here, even if you're not sure, you can update. It tells you the total range that you have, right? Remember, we had one big IP. We split it into two. So there's like one on the other half that started from 000 up till 127, right? 2555 like that. And then this is the second half, right? So once you have this second half, you can also decide. You can even say whatever is on the left is my prod. That's what my prod is going to be known for. Maybe what's on the right is going to be what my dev is going to be known for. And then within your dev network, it now depends on how many VPCs do you have in your dev network, right? You cannot begin to break your dev down completely and be like, okay, in my dev, I have like, if this is 9 already, it means let's assume that I have 4 VPCs. I can break this down into, this is already divided by 2, divide this by 2. I can break this already to 4 VPCs, right? So this becomes like 4 VPCs in dev. And then what it means is that I can take this now as a CIDR for a particular VPC and then break that into subnet. So I can divide it. If I know that this is going to be like my dev, one of my dev VPC, for example, I can divide it into subnets. Either ways, nobody does all these calculations by hand, okay? So if remember I was breaking whatever was here, I can break it down. If I know I needed 4 subnets, it's going to be, the most important thing you should keep track of is how many IP addresses do you want to have. This already have like 524,000. I don't know if that's what you want. For the most part, maybe you don't need that much. So what it means is that some people will even start from here and be like, okay, we don't need that much. So ideally, you can say, maybe I actually want to start dev as 10.10, and then you say everything is going to be /18. So meaning everything I know is going to happen in dev shouldn't take more than 16,000 IP addresses, right? In my dev account. And then you can break this further. You can say within this, have like how many VPCs do you want to share this with? So if you have like 4 VPCs, but again, like I said, you have to think about expansion, right? But once you can master this, you can basically start creating VPCs. Because the most important thing is that once you have those CIDRs arranged, subnets arranged, you know how many subnets you are getting from this full number and how you want to break it into proportion in terms of like how many hosts do you want to support in your private or public subnet. Once you break all that, it becomes very easy for you to now, because subnet will just ask you, what's the CIDR, right? Because he wants to know how many IP addresses do you want to support within that subnet. It's not a subnetting, it's not the deep networking class, but just be able to play around it. If you see a VPC that you're not clear with, right, just bring it here, throw the CIDR here, and try to do the calculation and see what it gives you. But for the most part, there is more to it. But like you can just from here get an idea, so that if you see a VPC, you'll not just be thinking, oh, there is like nobody does the calculation by hand. Like you won't be using paper to do the calculation, but it's just you just need to be able to have an idea of like when something is here, how many IP addresses are going to be in, and then something like this can actually help you tell how that can be broken down, right? Because I think when I was showing you the default VPC in the other class, I showed you default VPC and I took the example of the side that they're using, and I said they have this side, right? Automatically depends on which route that I'm going, but I prefer to go this one. And if I update this, I think it's slash what now? It's slash 16. So I'll go to slash, I think it's going to be slash, okay, I think it's wrong. So this has to be slash 16. So if I update, so that VPC itself, I know it supports 65,000 IP addresses. That's the most important thing for me. So it means that, yeah, that's how it was designed. The VPC was maybe you can design it at a high level and break it down up to this point, right? So it means that if this is 16 and this is just one VPC, what if you have like 10 of them? It means you have to be able to max this up to like 10, right? That means whatever is the 10th is like the topmost that you're going to use. But this you can further break it down, right? So I'm sure they broke it down once or left this. This is still free. Broke this one down. Broke this one down. So if you check the VPC itself, it has like 4 subnets, right? So it has like if you look at the subnets, it has like 4 subnets here. So let me order it according to the CIDR, right? So 17, 31, 00, 16, 32, 48. The most important thing is the subdivisions that he wanted to have. But if you break this down, which is exactly what they did, you see that it's slash 20, slash 20, slash 20, another slash 20, right? So these were the things that came. This first 4 is exactly what was done for us. This first 4, right? This first 4 was what was done. And what I did was to now break it further, right? So I broke this, and then I took the next one. So this first 4 was given to me, right? So this first 4 was given to me, and I created this next one, right? I can also create the next one from here. The most important thing, I know it needs to have like 4,094 IP addresses. Once you know this, honestly, it becomes very easy, right? But again, like I said, it's good for you to understand this in case you were doing it manually. But if you were doing it in code, Terraform, for example, there's a way you can have one side and then it breaks it down. But it's good for you to know how to calculate, because subnet planning is also important. You have to start from subnet planning. You need to know like, okay, how many IP addresses do we need for a subnet? And then start from the top and then break it down, right? So start from like overall IP, then break it down into like more or less like the VPCs that you want to break from the top IPs, and then break it down into how much subnet you want to have per VPC. And then all that will bubble up to give you the total IP addresses that you're using against what is left, okay? Please take note of these 2 URLs. This is CCP class. It's not an advanced class, but I want you to be able to go here. Whenever you see a VPC and you're not very clear of what it looks like, just come here and play with it, right? But if you do the math, it's really like I said, 32 minus 16, 2 raised to the power of that will give you this the total number, right? So for example, this one will be 32 minus 20, 2 raised to the power of that will give you this total host, right? And then because this is the range, the first IP address will obviously be 1.2.3.4 up to 255. Then this one again will start counting from 1. Okay, this is just CIDR 101, but you need it to really understand, because if at a point you want to start designing your own VPC, whether you are just playing across your accounts, you will need some of this basic knowledge. Okay, that's really what I wanted to add, because from here we'll not be talking about VPC again. We'll be going into more or less like advanced networking. So I wanted to really clarify this area before we close this chapter. But yeah, if you have any question from the class, you can. I just need to go back. Please make sure you're tearing things down, because interface endpoints, like I said, it comes with a cost. So here, obviously, we've already, I think it has disconnected me, but I just need to go back and tear down the interface endpoints, okay? Because, like I said, gateway is free, and interface endpoint I'm going to be paying. So for that reason, I'm going to this one is free. I think this the instance connect is free, but I'm going to tear this one down, the one that I just added. So I'm going to do delete for the S3 interface endpoint. So just make sure you clean that out. Yeah, so that one is deleting. What else? I think that's majorly security group. All that I'm not going to be paying anything. For my EC2 instance that is still left, it's fine because it's T2 micro. So I don't need to worry. That's the most important thing I need to take out from this class. Okay. And that brings us to the end of VPC basically. So VPC basic. We'll talk about the networking, the advanced part of networking around VPCs in the next class. So we'll go into our quiz. But please, if you stay back at the end of the class, use this time to ask any question you're not clear, especially around this area, so that we can talk about it, just to make sure that it's clear enough. Okay.